Let us write down the IUPAC name for this molecule. Let us first number it left to right 1, 2, 7, 8. Here the double bonds are at 2 and 4 positions and the triple bond is at 6 position if we number left to right. On the contrary, if we number right to left, then 1, 2, 7, 8. Now the triple bond is at 2 position and the double bonds are at 4 and 6 position. This also gives 2, 4, 6 as a set, and the other numbering scheme also gives 2, 4, 6 as a set. Therefore, we have a tie. Whenever we have a tie, we need to give preference to the double bond, and therefore, we should choose this our correct numbering scheme. Therefore, the correct IUPAC name for this molecule is octa. The reason we put the A here is because we have an alkadiene plus alkyne. So, whenever you have an alkadiene, for better phonetics, we put the A. Octa 2, 4 diene 6-ine. That is the correct IUPAC name for this molecule. Here is our next example. We have an alkyne, and this example is somewhat deceiving in the sense that if you think like this is ethyl group and we have couple of methyl groups, then you would be choosing a wrong IUPAC name, because this is not the long continuous carbon chain here. The long continuous carbon chain should be this one that contains 7 carbon atoms. We need to expand the ethyl group there. That should be our long continuous carbon chain. Number it 1, 2. The reason we number right to left here is because we need to give lower number for the alkyne. 3, 4, 5, and then we have 2 carbon atoms here, that will become 6 and 7, because when you expand and write it, it will be CH2, CH3 and then whatever the rest. So, this means that we have total 7 carbon atoms in our long continuous carbon chain. Therefore, the root word is hept. That means we have 3 methyl groups. So, the correct IUPAC name for this molecule is 4, 5, 5 trimethyl hept 2-ine. That is the correct IUPAC name for this molecule. Here is our next example. We have an alkyne. Once again, we have 3 methyl groups here. This means that 2 will become substituents and 1 will become part of the parent chain. Here also we have 2 methyl groups. That means 1 will become substituent and 1 will become part of the parent chain, and therefore let us expand and write this CH3, C, CH3, CH3 and then C, triple bond C, CH, CH3, CH3. Therefore, here our parent chain is this one, and that has 6 carbon atoms. Let us number it left to right 1, 2, 3, 4, 5, 6. So, if we number left to right, the methyl groups are at 2, 2 and 5 positions. On the contrary, if you number right to left 1, 2, 3, 4, 5, 6. Now the methyl groups are at 2, 5, 5 position. In either way, the alkyne is coming at 3 position. However, here the methyl groups are making the difference. So, the left to right is the correct way of numbering here, because that gives lower numbers 2, 2, 5. Therefore, that is the correct numbering scheme here. Therefore, the IUPAC name is 2, 2, 5 trimethyl hex triyne. That is the correct IUPAC name for this molecule. Here is our next example, ethyl-isopropyl acetylene. We know that this is the structure of acetylene. We need to replace the hydrogen atoms and put ethyl as well as isopropyl groups, but we cannot put both ethyl as well as isopropyl on the same side. If we do that, then we will be messing up with the valency of carbon. Therefore, on one side you put the ethyl group, and then on the other side you put the isopropyl group, that is CH, CH3, CH3. So, this is our long continuous carbon chain here. Let us number it 1, 2, 3, 4, 5, 6. If we number left to right, we get the triple bond at 3 position and the methyl group comes at 5 position. On the contrary, if we number right to left 1, 2, 3, 4, 5, 6. Once again the triple bond is at 3 position. However, the methyl group comes at 2 position, and therefore this is correct now. Therefore, the IUPAC name is 2-methyl. We have 6 carbon atoms in the parent chain, hex triyne. That is the correct IUPAC name for this molecule. Here is our last example. We have an triyne because we have 3 triple bonds in this molecule. Let us number it left to right 1, 2, 3, 4, 5, 6. The triple bonds are at 1, 3, 5 position if we number it left to right. Even if we number right to left, we will get the triple bonds at the same position 1, 3, 5 even if we number it right to left. Therefore, numbering it either way is completely okay here. We have 6 carbon atoms in the parent chain, therefore hexa 1, 3, 5 triyne. That is the correct IUPAC name for this molecule.